Please let me just take you back for a while. Remember, yesterday we looked at this problem. At this problem, we said, in here they said to us, graph the function f given by f of x, which is equals to 2x cubed minus, I'm just trying to bring you up to speed.
Yes, sir.
Graph the function f given by f of x, which is equals to 2x cubed minus 2x cubed minus 3x squared minus 12x plus 12. Then, how did we draw this? Remember from, I think, standard 6, grade 8, ne? Yeah. So,
Yeah.
standard 6. I mean,
Yeah,
standard 6.
This is grade 10. Grade 10, sir.
No, grade 10 is standard 8.
Oh, okay. Hey, the standard second.
Oh, great. Okay, let's say the first grade in high school is grade 8, ne? Yes. Yes. In other ways, I just need to say, what I'm just saying is to say, in high school, I can't remember whether it's grade 8 or grade 9, but that's where we encountered this type of graphs. Remember, to draw this type of graphs, then we used points. We created a table, and then let's say we had 0 in the middle. Then we took 2 numbers from the left and 2 numbers from the right. Then those we referred to as the x values. Then we substituted them in the given equation in order to correspond in the y values.
Yes.
So that is what they did over here. Then from there, they then, let me say, they then started focusing on what we are mainly focusing on in this section. Then they took the first derivative. Good evening, Lerato.
Good evening, sir.
Hi, Lerato.
Hi, Lerato.
Hello, ma'am. How are you?
Good, and how are you?
Hi, hi.
Then
wena liphuti ka jalo le dikgoshigadi. Sure.
You are the queens. So probably my sister, probably Lerato didn't even understand what you said.
She understands.
Really?
Things she doesn't understand. Yeah, Lerato, and if it was Zungu, yeah, I would say Lerato, she understands.
Okay. Then
what am I understanding? Because I joined late. Sorry, guys.
No problem.
But it looks like we're recapping what we did yesterday, ne?
Yes, we are recapping. Yes.
Okay, Lerato, do you understand? Do you understand when they say Uhoshirad?
No.
You see, I told you.
I lost. I lost the bet.
I guess, yeah. What were you betting?
That you understand the word. That you understand the word Hoshirad.
Oh no, let me just say, because you guys have been speaking, I might be Lerato Mara. I don't understand anything. Don't ask me, why not? I know my dad messed up. He should have taught me. But my mom then was also wanting to teach. So it's like, okay, how do we speak to the child? So both of them decided we won't. So that's the situation.
Okay. Yeah, I understand now.
Okay. Don't worry, we
understand. You didn't have that insider information, but your bets were
wrong. So say it was correct. I was wrong.
All right.
What does it mean, though? What does it mean?
Queen.
It means that today we are the queens because there's only 2 of us. It's a special
I didn't even
session.
see.
It's a special session today because there's only 2 of us.
The other ones ran away.
I think so. Because it's a Friday mood, you understand. People are
Yeah.
yeah.
But
Yeah.
we make the time.
Yeah.
Yes, it's important. When that day arrives, you will cry. I mean, people will be crying for each and every moment that they had.
Yeah. True, sir.
Okay, let me just start from where I started. Okay.
Okay.
Yesterday, Lerato, we are just recapping.
Okay, so perfect.
Yes. Yesterday, we looked at this example where they were requested to graph the function f given by f of x, which is equals to 2x cubed minus 3x squared minus 12x plus 12. Then they use the table. Remember the way I was just telling Pruti to say in standard 6, 7, which is grade 8, 9. I think that's where we started drawing these types of curves. So
Yes,
in
sir.
there, we used, remember, we just said, okay, 0. Then we said 1, 2, 3. Then we said -1, -2, -3. Then those were the x values. Then we substituted in the
Functions.
In the functions to get the corresponding y values. Remember,
Yes.
that's how we started.
Yes, sir.
Yes, sir.
Yes. So that is why you see this table is just how we started. So then the next thing that they did, these people, they found the first derivative in order to get the critical points. Okay? So
yes,
the first derivative of this is 6x squared minus 6x minus 12, as they have it here.
Mm-hmm.
Then from there, this is the first derivative. The next thing to be done was to put the first derivative to be equals to 0 in order to solve for the x values. Then here we see that common factor is 6. They divided by 6. Then this equation then became x squared minus x minus 2. Then the factors became x plus 1 and x minus 2. Therefore, solving, x is minus 1 and x is 2. Then from there, let me just take you back to the number line. The number line at the center is 0. To the left are negative numbers. To the right are positive numbers. Okay. Then, to the left of 0, from one of the critical points is -1. Okay? To the right of 0, one of the critical points is 2. So now, this is what we are saying. We need to form intervals coming from these critical points, these two critical points. So, -1. Okay. Coming from the far left, that means we are coming from negative infinity. When we come from negative infinity, when we go to 0, then the number that we will meet, that we have, is -1. Do we agree? That is why then we have got this interval, minus infinity and -1. Then, from there, remember we are coming from we came from the far left. Then we encountered -1. That's where this interval is coming from. Then from there, where are we going? We are going to +2. Because from -1 is 0. Then the next number that we'll encounter as our critical point is +2. So that is why now our next interval that we have got -1 and 2. After that, we will have to take an interval beyond 2 to the right. Why are we doing this? This will help us to be able to see where this function is increasing and where the function is decreasing. How? We are going to draw that table of signs. So I don't know. That's my thinking. I don't know whether you understood that table of signs or not, which indicates where the graph is increasing and where the graph is decreasing. But we did talk about it. So now we'll talk about it again.
Okay, sir.
Okay, sir.
Then, don't be confused. -1 and -2. This is a number line, as I said. We can consider this B to be 0. Okay, then there should be a 1 here, 2, 3 going far to the positive right. Then 0, -1, -2 going to the far, going far until you get to -infinity. So from here, then the next thing, after getting the critical points and then getting the intervals based on the critical points, then the next thing is to what? Please write down this. I want to simplify this thing for you. For now, okay, you saw this. Then now you are not writing anything down. We'll write after this. Then our critical points are, oh, what did these people do? Oh, they chose. All right. Now is important. Yeah, I think now you need to, I will request you to write what I wrote. Where is this? Okay. Please draw a table. 2, 3, 4. Draw a table that will have that will have 1, 2, 3, 4. 4 rows, eh? Are you with me?
Yes, sir.
4 rows, and then how many columns? 1, 2, 3, 4. 4 rows, 4 columns. Please tell me when you are done.
Done, sir.
Done. Okay.
Yes, sir.
This is, we refer to it as a table of signs, is what we are, what you just drew. Then in row 1, in row 1 of this table that you drew, please write interval. Okay?
Yes, sir.
Then in the next column, in row 1, please, in the curly brackets, please write -infinity, -1, then close bracket.
Sir, can you repeat what we must write in the second column of the first row?
Open bracket.
Yes.
Minus infinity.
Yes.
Comma minus 1. Close bracket.
Thank you, sir.
You're welcome. In the next column, which is the third column in row 1, please. Oh. Mine. Okay. In the here I was working on a different exercise, but it's not a problem. Let me just amend my numbers here. Okay. Let me say in the first column, in the first row, I requested you to write the word interval. Then in the second column, open bracket, minus infinity, comma, -1, close bracket. In the next column in row 1, then you will have open bracket, -1, comma, 2, close bracket. Then in the fourth column, in the first row, you will then have 2, comma, positive infinity. Are we together?
Yes, sir.
Yes, sir.
Then in the second row, in the second row, in the first column, please write test value. Done.
Yes.
Yes,
all right,
sir.
Okay. Now, whatever that we are doing should talk to each other. Remember, it is test value now. Now, in the second column in row, in the second column in row 1, we have got minus infinity and -1. Okay.
Yes. Yes, sir.
Please choose any number of your choice between, or maybe not to confuse you. Let's just stick to, okay, we'll stick to these numbers that they used here, but let me first explain. Do we agree that from the number line, from 0, when we go to the left, from 0 we'll have -1, -2, -3, -4, going down there.
Yes.
We agree?
Yes, sir.
Okay. Now, let's talk between minus infinity and -1. You see, that is the second column in row 1. Okay? Meaning you choose any number of your choice between minus infinity and what? And -1. All right?
Yes, sir.
In this case, they chose -2. Do we agree that -2 is between -1 and minus infinity?
Yes, sir.
All right. So in this case, we'll stick to these numbers, but so that you can be able to follow this example. But what I'm just saying is to say, you choose one number that lies in this interval. Whether you choose -4, whether you choose -3, whether you choose -5, that number is to the left of -1. Eh?
Yes.
And between negative infinity. Any number that you choose, you stick with it. Okay. But in this case, they chose -2. Am I making sense?
Yes, sir.
Thank you. Now, please, in the second column in row 2, then we will have that -2. Okay?
Yes, sir.
You will write -2. This -2. This -2. Yeah, because here they said the test values we choose are this -2 is to the far left of -1. So you will write -2 there. Then now we'll go to the next interval. Third column, second row. Okay? A number between -1 and +2 that they chose is 0. Do we agree that 0 lies between -1 and +2?
Yes, sir.
Yes, sir.
Thank you. Another one that lies between -1 and 2 is 1. Okay? But in this case, as I said, I'll stick to what they used so that you can follow. If we are different, someone might have chosen 1. So I'm just showing you the logic behind this. So they chose 0. Then in the last column in row 2, what is it that they chose?
4.
4, sir.
4. They chose
Yes,
4 because this 4 is between +2 and what? And +infinity.
Infinite.
Is it making sense?
Yes, sir.
Yes, sir.
Okay. Now, you and I we're going to do this and this at the same time. Okay. Remember, your table of sign is interval. Oh, I said interval test value in the third row in the first column. First column, third row. You will then write sign of the first derivative of f. Are you with me?
Yes, sir.
In the last row of the first column, you will write result. Done. What your table now at this point in time, in the first row is having interval, and then interval next a column is having in brackets -infinity, comma -1. In the next column is having -1, +2. In the last column is having 2 and +infinity. Do we agree?
Yes, sir.
Then in the second row, in the first column, you have got test value, sign of first derivative, and then result. And then
Yes.
For test value, the numbers in that row, you've got -2, 0, and 4. Do we agree?
Yes, sir.
Yes, sir.
Okay. Now, the next thing that we need to do is to complete or to populate row 3 and row 4. Okay.
Yes, sir.
Okay. How do we then do that? Easy. Yes, I changed this on my side because this was for a different exercise. So, in the second column, in the first row, we have got negative infinity and negative 1. Test value is -2. Do we agree?
Yes, sir.
So we take that -2, we substitute it into the first derivative. Remember, this is the first derivative. 6x squared minus 6x minus 12. Here, 6x squared minus 6x minus 12. Do we agree?
Okay,
Yes,
so
sir.
I do agree. So can I please ask something?
Yes.
So for finding the sign of, like doing the sign table, only use the derivative to substitute the critical points. You don't use the normal, the first function that we got, like before, like we used to substitute back to the function and then say, oh, this is a local extrema, what. So now we just substitute to the derivative, the
Yes.
test, because it's the test
Yes.
values, it's not actual critical values.
We are not looking for the corresponding, we are not looking for the values that are corresponding to the critical points.
Yes, so that's why we're not substituting back to the original. We're substituting to the okay. Thank you, sir.
That is why you see my cursor here. You see here.
Yes, I see the cursor. Yes.
Yes, that is why then in the second row, in the first column, the way I requested you to draw that table, you will be having sign of the first derivative of x.
Yes,
sign of first derivative of x. Yes.
Yes. Okay. I understand.
Now, okay, you are welcome. You are welcome. So then we take the -2, and then now it is clear to you where the -2 is coming from. Okay? Now you take the -2, you substitute in the first derivative. Then when you simplify, please double check from where you are sitting whether you are getting this positive 24 or not. I'll keep quiet.
Okay, sir.
We are just recapping what we did yesterday. Okay. I just need to make sure that all of you understand this, so that if you can be able to understand just this one, believe me, then you are going to understand everything that follows.
Okay.
Yes. Where you don't follow, please ask. Now these are the critical values that we got. This is the function. And Mahabe, I'm just trying to bring you up to speed. This is the function. Then from there, we got the critical values to be -1 and 2. Then from these critical values, then we created the intervals. The intervals that we created are -infinity and -1. The next one is -1 and 2. And the last one is +2 and +infinity. Yes, we have got 2 critical values, but our intervals are 3, because -1 coming from the far left, that's where we have got this negative infinity is coming from. Clear. Then -1 and 2, that is why we have got this interval. And then 2 and infinity, we know that from 2, then we are going to +infinity. And Mahape?
Yes, sir.
Okay. Then I requested them to draw the following table. Please try to be faster so that we can be able to move. Please draw this table. This table has got 4 rows and 4 columns. And then 4 rows, 4 columns, I'll tell you what to write. Lerato, Puti, I requested you to...
Yes, sir.
Yes, sir.
I requested... Oh, all of them?
Yes.
Oh, okay.
Yes, sir.
Oh, you agree that the first, when you substitute -2 into the first derivative of f, you say you get positive 24, né? Which is greater than 0. And then when you substitute 0 into the first derivative, you are saying you get -12.
Yes,
Finally.
Sir. Yes, sir.
Finally, 4, then you say you are getting 60.
Yes, sir.
So, here is what I then need to talk to you about. Okay. Remember, in the test value, row 2, column 2, x in there is equals to -2, né?
Yes, sir.
In that table that I requested you to do.
Yes, sir. The test value we gave that interval is -2.
Yes. In that column, okay, let me quickly just repeat this. In the first column, in the second row, first column, second row, you've got test value. Then this test value, then in the second row, second column, you have got x equals to -2. Clear?
Yes.
Sir. Yes, sir.
Lerato, do you follow?
Yes, sir.
Okay. Then, from number A, the first derivative, when you substitute -2 into the first derivative, they got positive 24. All right? So, that positive 24 is greater than 0. That's why they are saying here, the first derivative, when we substitute -2 into the first derivative, we get positive 24, which is greater than 0. Do you agree with them?
Yes.
So
yes, say, can I please ask? So you always reference when you're checking the sign with 0, like if it's greater than 0 or less than 0.
Yes.
Okay.
Yes. Okay. I think there is a definition or a theorem that we talked about. I'll take you back to it. Don't worry. Then the next thing that I'm requesting you to do, remember, now it is a second row, third column. You have got x equals to 0, né? Oh, yes. You said you calculated all of them. That means I can talk to you about all of them at once.
Yes,
in the second row, third column, we have got x equals to 0. Then, when you substituted, you got -12. You agree?
Yes.
And then -12 is less than 0. Okay?
Yes, sir.
That's why then here we've got this statement that is saying, when you substitute 0 in the first derivative, you get -12, which is less than 0. You don't put that number. You just say, that number is less than 0. This is what we didn't talk about yesterday, yeah?
Yes, sir.
Yes, I didn't want to confuse you. I just needed you to make sense out of this. That's where this is coming from. Is it making sense?
Yes, sir.
The next thing, remember, and last point that was chosen was 4. Then we substituted it where? In the first derivative. They got 60, and then you agreed with them. So this 60 is greater than 0. So 60 is greater than 0. So that is why you will have the first derivative of 4, when you substitute 4 into the first derivative, you will end up having 60, which is greater than 0. Is that making sense?
Yes, it makes sense.
Yes, sir.
Now we are going to the last row. Our last row of the result. This. When the first, okay, we substituted -2 into the first derivative, and we got a number which is 24, which is greater than 0. If that number is greater than 0, that tells you that the function is increasing over the interval. Remember, at the top, you are having this interval, né? Minus infinity and -1. On top here, the way I asked you to draw the table, the way I requested you to draw the table. So then, whether you repeat it here or what, it doesn't matter. But as long as you have got it here at the top, the way it becomes much easier for me if the interval is at the top, because it flows nicely. You are also able to see that, okay, this value of x that was chosen is coming from this interval. I don't know whether you get me.
We get you, sir. Understand.
Yes. Then, from there, if the number that you got is greater than 0, you just say f is increasing. Okay? F is increasing, your interval will be at the top. Whether you write it here, but in my case, it works best if this interval is at the top. Then you'll be able to say f is increasing. Where? Then you refer to that interval. Okay?
Yes, sir.
The next one. The next one, when we substituted 0 into the first derivative, we got -12. -12 is less than 0. So that is why we're saying when you substitute 0 into the first derivative, we get a number that is less than 0. Therefore, the interval here is -1 and 2. Therefore, f is decreasing because the number that we got is less than 0. Are we clear?
Yes, sir.
Yes, sir.
Finally, finally, when we substituted 4 into the first derivative, we got 60. This 60 is greater than 0. Then when you come here, you'll just say, when I substitute 4 into the first derivative, I get a number that is positive. So that number, I got 60. This 60 is greater than 0. That is why we just write, you will just write greater than 0. And then, if it is greater than 0, then f is what? Is increasing. Is this table making sense? Because if you follow this table already, let's say from the first column of the result, you see that, okay, when I draw this curve will be increasing. It's guiding you. This result is guiding you to say, okay, between -1 and -infinity, this curve is increasing. But between -1 and 2, this curve is decreasing. And then from the interval 2 and +infinity, this function is increasing. That is the whole idea. Is this clear?
Yes, sir.
I felt it being important for me to take you back to this, because yesterday I didn't explain it. And then I thought that no, some of you will just struggle. Now, from there, now we go back. And Mahape, do you follow?
Yes, sir.
Are you sure?
Yes, sir.
Okay, I will catch you. I know where I'll catch you. I'll catch you. Catch you. The idea is not to catch you. The idea is to make sure that you understand. All right, my sister? Thank you.
Yes.
Then, how do we then get the corresponding values for the critical points? Only critical points. Okay. Our critical points are -1 and 2. So we'll have to get the corresponding y values. How? Puti, where do we substitute now?
To the original equation, sir.
Into the original equation. So, by the first derivative, we are not yet on the second derivative. We are still on the first derivative. Take one of the critical values of your choice. There are 2 minus 1. Substitute into the original equation, then gives positive 19. Then, if this number is positive, I'll also take you back to refresh your memory in terms of why the relative maximum. If this number is positive, that tells you this is the relative maximum. The way we spend time here with me trying to show you how to tell before even drawing your graph, how the shape that it will take based on the points that you will be having. This simplifies everything. That is why it's important. Then, now, f of -1, the corresponding value for -1 is 19. This will be the relative maximum point. Then when 2 is substituted into the original equation, it is giving a negative number. So this will be the relative minimum. Thus, there is a relative maximum at -1 and 19, and a relative minimum at 2 and -8, as we suspected from the sketch of the graph up there. Okay, in this case, you already saw the graph. If that graph was not there, we're just going to use all these points that we calculated to draw the graph. And then what would be of great importance would be this column from this table of signs. Because these values or these coordinates will have to talk to this. Once they don't talk to each other, then you must just know that you made a mistake somewhere. Then yes, this point where x is -1, y is 19, where x is 2, y is -8. Then please allow me to minimize this. I need to show you. Do you still see? I need this table and this graph on one page. Are you still able to see?
Yes, sir.
Yes.
All right. Now, please, let's talk about this last column of the table that you drew. Okay? We said between -infinity is somewhere there. Between -infinity and -1. This is -1. What are we saying? We say the function is increasing.
Sir,
Yes.
can you please try to zoom in? I can't see.
Okay, I will zoom. Okay, but do you see the page that I'm on now?
Yes, I can't see it.
at all? Is that she?
It's
Your name again, man?
sir.
Lesedi.
Is
Hi,
Lesedi?
Lesedi.
Hi, classmates. Hi, family.
Lesedi.
I'm sorry, sir, I'm late. We had load reduction here, so I couldn't attend the class.
No problem.
Yes, sir.
Now, I needed. Okay, then Lesedi. Family
Yes.
members, everybody, remember we said between negative infinity and -1, this function will be increasing, okay? Negative infinity is somewhere down there. You see this line down there to the far to the left. So now we expect this function to be increasing. So the way we drew it, to be increasing, yes, to be coming from somewhere down to here. Are we together? That is why we are having it here, increasing. -1 and negative infinity. It's referring to this part, this part to the left. Is it clear?
Yes, sir.
Yes, sir.
Now, we come here. F is decreasing over the interval of -1 and 2. Okay, between 1 and +2, we expect this curve to decrease. Here, this curve is decreasing. Do we agree?
Yes, sir.
Yes, sir.
Now we go back to that table. That last column, okay, between +2 and +infinity, we expect the function to increase. Yes, from here, going far to the right, this function is increasing here. Are we still together?
Yes,
Yes,
sir.
sir.
Okay. That is the importance of that table of signs. And then the last important thing, usually when they ask this type of questions, is to indicate the following. These bullets, these ones are in blue. Okay. Now, they say, for reference, the graph of the derivative is shown in blue. Oh, this one is of the derivative. Shown in blue, note, first derivative equals to 0, where f has relative extrema, is the function in red. We summarize the behavior of this function as follows, by noting where it is increasing or decreasing and by characterizing its critical points. Now, we'll have to explain or to tell them that the function f is increasing over the interval -infinity and -1. Then the next thing that is there, the function has a relative maximum at the point -1 and 19, which is that one. The next one, the function f is decreasing over the interval 1 and 2. It's this one. The function f has a relative minimum at the point 2 and -8. And finally, the function f is increasing over the interval 2 and +infinity. In that case, then you would be done. Is it clear? Is it making sense?
Yes,
Yes,
sir.
sir.
Yes, sir.
Yes.
Okay. Now, I hope that you are, the most important thing, if I can just sum it, in less than a minute. You'll be given a function. From that function, what do? You get the critical values. After getting the critical values, what do you need to do? You need to create the intervals. From the intervals, you need to establish the intervals. Then you draw a table of signs. After drawing a table of signs, then you will be able to see where the graph is increasing or decreasing. Then from there, you calculate the relative maximum and the relative minimum. And that's it. Okay. Now, let me, any question? Lizzie, any question?
No, sir. Since from so far I understood from I get more kicky, but the part in we touch from yesterday, the last part.
Yes.
Yes, so
yes.
yeah, I understand the meaning.
All right.
Thank you.
Fuji, Lerato, are you still with me?
Yes,
We're here, sir. We're here.
Okay. Okay. Please sit still. Play still, sit still. Then do you see example number 2?
Yes, sir.
Yes, sir.
Find the relative extrema of the function f given by f of x, which is equals to 2x cubed minus x to the power 4. This question is requesting you to do all those steps, all of them. Everything that we did in the previous example is requesting you to do just that. How many seconds or minutes do you need to work it out?
4 minutes. So I'm done, but I don't know about the sketching.
What is wrong with the sketching, if I may ask?
So I don't know how I'm supposed to draw it. Obviously it mustn't be straight lines, right?
Okay. Here is my question to you. Did you get the critical values?
Yes, sir.
From the critical values, then did you get the intervals?
Yes, sir.
From the intervals, did you create that table of signs?
Yes, sir.
The way I requested you to create it. Interval.
Yes, sir. I think maybe with one of my intervals it might be wrong because I have the same sign on both sides. Like if the interval splits the number line into 3 segments, for the segment on either side of one of my critical values, I have the same sign.
Okay, Lerato. I heard you. Then please allow me to complete what I was just saying. In the first row, in the first column, did you write interval?
Yes, sir.
And then in that first row, did you write all those intervals that you had according to the critical points that you got, or the critical values?
Yes, sir.
Then the next thing, in the second row, in the first column, you will write test value. Then you will choose one number in that interval for
Yes,
all
sir.
the intervals. Is that what you did?
Yes, sir.
Then, in the third row of the first column, you will have a sign of the first derivative of f of x. Is that what you have?
Yes, sir.
That will be completed after substituting those values that you have chosen in those intervals that you had in the first derivative.
Yes, sir.
If you did that, then your last row, according to the sign that you got after calculating, after substituting the critical values in the first derivative, then you will be able to tell where the function is increasing or decreasing. Is that what you did?
Yes, sir.
After that, you'll take the critical values, substitute in the original function in order to get the corresponding y values to form, in other words, to form the coordinates for the relative maximum and the relative minimum. All right. Please ask other family members whether they are done or not.
Puti, Lisedi, Mahape, are you guys done?
Yes, I'm done. It is done.
All right, Puti, you are done. Lisedi,
Yeah.
are you also done?
Yeah, say I think so.
You can't say you think so.
Say
Lisedi,
many
you can't think so.
say, but yeah, I'm done.
Yeah, you see, that is the answer that I needed, my sister. Okay, now let me create this space on the side of this page. All right. And now, where do I start? Okay, I'm starting with Lisedi. Lisedi, what is the first derivative? What is the first derivative?
My first derivative
Hmm.
is, say I get it from the real equation. I got 6x squared minus 4x cubed. I don't know if I'm correct.
Please repeat.
Pardon?
Please repeat, my sister. First derivative.
Okay, my first derivative, it was 6x squared minus 4x cubed.
What's wrong? I agree.
Okay.
Puti, do you also agree?
Yes, I agree.
All right. Now, the next thing is to put this to be equals to 0. So we've got 6x squared minus 4x cubed equals to 0.
0.
We agree?
Yes, sir.
Now, tell you? Okay. No, let me not tell you. Please tell me.
Oh, okay.
Yes, then you tell me. From here, where did you go and what did you find?
Say according to my understanding, knowing that like 6x squared and 4x cubed is not in, is it ascending? Yeah, ascending order. So I derivated it again, and then I got 12x minus 12x squared, and then I equated it to 0 again. I don't know if I'm correct.
Lizzie, what did you do?
I equated it to, I derivated this equation again.
The first, again?
Yeah, the second one.
Why?
Okay, so So am I wrong? Family, please help.
So, okay. What you will go?
The sun shapaka po mo tle ko palintsiseng.
While Rato, you're saying footies. Okay, we can't do the second derivative.
Okay.
Only working with the first derivative because we want to check for the relative extreme. Yes.
Oh, okay, okay.
That's where you lost it.
Okay, so yeah, now I see.
Okay. Between Puti and Lerato. Yes, thank you, Lesedi. Lesedi has got calculated the first derivative. And then she found the first derivative to be 6x squared minus 4x cubed, which I agree. Then the next thing is to put 6x squared minus 4x cubed to be equals to 0. My question is to say, what are the critical values that you got?
Okay, so so I got 0 and 3/2.
I also got that.
You got 0
and 3/2.
Wait, let me see. Take 2x squared outside, then I'll have 3 minus 2x equals to 0. 2x squared will be equals to 0, or 3 minus 2x equals to 0 minus 2x equals to minus 3, so x equals to 3 over 2. 0 and 3/2. Do we agree?
Yes, sir.
Yes, yeah.
Thanks.
Okay, so they do agree, so I'm left out.
Sorry?
I can more 6x squared and then after the first derivative because I derivated the first derivative. So from there I could say
No. Listen, you were only supposed, you and I, remember, you and I are on this journey together, okay?
yes.
You found from this given function, the first thing to do is to get the first derivative, okay?
Yes.
Which you found to be 6x squared minus 4x cubed, okay?
Yes,
We agree with you and then we appreciate the effort, okay?
Yes,
Then the next thing that you should have done, okay?
yes.
Was to put this first derivative to be equals to 0 and solve for x.
Oh.
The critical values.
Okay. So yeah.
The wheels came off when you went further to find the second derivative.
Yes, yeah, I do understand now. Get you.
Okay. Now that we've got x equals to 0 and x being equals to 3/2. And now I need to talk to these two sisters of mine. These two will trick me if I talk to them at once. Let's talk to them individually. Puti?
Yes, sir.
I'm now looking for the intervals.
Yes, sir. Okay,
what are the intervals?
Okay, so since we have 0 and 3/2 critical values, our intervals will be negative infinity, comma 0, the first interval, which is it goes from negative infinity to 0, close bracket. And other one it's open bracket 0 and 3/2, close bracket. And then the other one it's 3/2, comma infinity, close bracket. So
positive infinity, Puti.
yes, positive infinity. Yes.
Lerato, is that what you have?
Yeah.
Thank you. The next thing that we need to do then, what is the next thing that we need to do?
The next thing, sir, is we need to then choose a test value for each interval.
Yes.
We draw that table. Oh, we choose the test intervals. Yes.
Because the table's already drawn, not just value in now.
No. We choose the test values.
Yes, test values.
Yes. We choose the test values. After choosing the test values, then we draw that table of signs.
Already says drawn. Okay.
Sorry?
We already drawn sign. That's the table.
Oh,
so just
is it?
the values.
Oh, is the table there?
Drawn, but there's no values in it yet. So in the table, we just have the intervals, and then now we're filling in the second row with the test values.
Did you have the test values in your table?
Yes, sir.
Oh, okay. Now let me have my table. This is getting interesting. The table, easy when you put it like this. Interval, and then next will be test value, sine of the first derivative of x, and then the result. Then I'm also drawing this table. Then interval. The first one is negative, infinity, and 0. Puti, do you agree? That's what you told me.
Yes, sir. I agree.
The next one, 0, 3/2. You agree?
Yes, sir. Correct, sir. I agree.
Then the last one is 3/2 and positive infinity.
Positive infinity. Yes, sir.
Thank you. Now, let's come to the test values. For negative infinity and 0, what did you choose? X equals to what? -1. Thank you. Now, where is that first derivative? When you put -1 in the first derivative, let me see, this number will be this, that, oh, wait. Oh, okay. Then, what is the sign that you got?
Positive.
Positive, sir.
Positive.
Sir.
Positive. First derivative of -1 is greater than 0. That is what you will write in the third row, third column. Second column, third row. Do we agree?
Yes.
Second column, third row. Now we are going to the okay. Let's just conclude this column. Then on the result, what are we saying?
It's increasing, sir.
Okay. F is this function is increasing. Now we are done with the first column,
Yes, sir.
Now we are going to the next column. The next column, where the interval is 0 and 3 over 2.
Yes,
Yes?
sir.
Which number did you choose?
Half, sir.
Half. Okay.
Yes.
Now we take half, we substitute in the first derivative. Let me just see first here. Okay. This one. Now this one will be that. And this one will be that. Then what did you get? What is the number that you got?
So I got it. It's greater than 0, but I see got against a mistake. But I got greater than 0, so
That's what I was also thinking. Because I chose, what did I choose? I chose 1, and I also got increasing. So this is where my confusion about drawing the graph came in.
Okay. Let's get this thing clear. Let's get it clear, my sisters. So this will be 6. This is first derivative of 3 over 2. Of half. Of half. This will be equals to 6. Half squared minus 4. Half to the power 3. Okay. Half. Okay. Now, let me do this. Half squared is 1 over 4, eh? Do we agree?
yes, sir. Yes, sir.
Times 6. So we've got 6 over 4, eh?
Yes,
First
sir.
term.
Yes, sir.
I'm interested in us getting the same number for this one. So the first number, 6 times half is 6 over 4. That is what we write, ne?
Yes, true, sir.
Then we have got half to the power 3. This is the same as 1 over 2 to the power 3. 2 times 2 is 4. 4 times 2 is 8. 1 over 8. Do we agree?
1 over, yes, sir.
So now this is 4 over 8, which is half. Do we agree?
Yes. 0.
So this is 6 over 4 minus a half. I simplified this 4 over 8. Okay. Yes, do you agree or not?
We agree, sir.
Okay. So now we have got 6 over 4 minus a half. Do we agree on that one?
Yes, sir.
Okay. Now our LCM is 4. Okay, 4 into 4, 1. Then we've got 6. 6 minus 2 into 4 goes 6 into 4 twice.
That's
Times 1 is 2. So now we have got minus 4 over 4, which is giving minus 1. Do we agree?
Okay. Okay.
People.
Sir, you're aware, because I got 1. I got 1. Yes, there. Okay. No problem.
6 minus
sir.
2. Remember, I simplified. We said 1 over 2 raised to the power 3 is the same as 1 over 8. Then
Yes,
we multiply by 4. This is the same as 4 over 8. 4 over 8 is the same as a half.
Yes.
That's why then I had 6 over 4 minus half.
Oh, okay. Yes, true.
So then this gives us minus 4 over positive 4, which is minus 1. Do we agree? Lisady?
Yes, sir. I'm here.
So, sir, you got minus 1 is the answer.
Yes.
Then I got 1.
You got 1. How?
Because I can say 6 over 4, it's like 3 over 2 minus half.
Wait. Okay. Let me listen to what you are saying. I'm keeping quiet. You are saying?
Sir. I'm agree with you, from 6 divided by 4 minus half. That's what I got also. Then we know that 6 over 4, it's like 3 over 2. Ne, sir.
Please.
Minus 1 over 2.
Wait. Yeah. Let me check something. Okay. I hear you.
Okay.
Then please proceed.
So yes, say, because 6/4 is 3/2 minus 1/2. So they have the same base. So I minus, which is 3 minus 1 is 2/2. Then which is 2/2, which is 1, say.
Okay. Let me do
Yes.
this. Wait. Now I see where you are coming from and where you are going. All right, Puti. Let me stick to what we have here, so that let's stick to what the numbers that we have. So that means we have got 6/4 minus 4/8.
Yes.
Yeah, these are the numbers that I'm requesting you and me to stick to.
Yes.
Oh, wait. Oh, but this thing is positive. What will be
It's
the
positive.
difference?
Yeah.
This is
It's
positive.
Yes.
This is positive half.
Yeah.
Okay. Now, I heard you. My request is that we not simplify. Remember, I had simplified 4/8 to be half. Ne? Now, please, let's not simplify. Our first term is 6/4 minus 4/8. Let's simplify this and let's see what we get. So we should get the same thing now. You didn't simplify the 6. You didn't simplify the 6/4. Then we are also not simplifying this term, which is 4/8. Okay?
Yes.
Yeah, we work with these numbers as they are.
Yes, sir.
So our LCM is 8. Okay?
True, sir.
Now 4 into 8 is 2.
2
times 2
times
6 is 12.
Yes, sir.
Minus 8 into 8, 1.
1.
1 times 4 is 4.
4.
Now we have got 12 minus 4. This becomes
8.
8. So this is 8/8, which is 1. We
True,
agree?
sir. Yeah, agree, sir.
Now we agree that in the third column, in the third row,
Yes, sir.
now this is positive 1. Therefore, the first derivative of half, the first derivative of half is greater than 0.
0. Yes, sir.
Therefore, in the last row of this column, what are we saying?
It's increasing, sir.
It's increasing. Yes. Lerato, are you still there?
Yes, sir.
Lisani?
Yes, I'm still here.
Okay, thank you. Now, anyone, what is the number that you chose between positive 3/2 and positive infinity?
So okay, anyone. I choose 2, sir. I chose 2.
You chose 2.
Put.
Okay. If you chose 2, now let's see. The first derivative of 2 is 6 times 2 squared minus 4, 2 to the power 3.
Yes,
this is 6 times 4 is 24,
True, sir.
minus 2 to the power 3 is 8. 8 times 4 is 32,
Yes, sir.
32. Now, 24 minus 32.
Minus 12, sir. Sir.
What?
Oh, okay. Maybe we can say minus
24 minus 32.
Minus 8.
Sorry, sir. Minus 8-ish. Okay.
Minus 8.
Okay, sir.
Okay, here x is equals to 2. And then the first derivative of 2 that you chose is minus 8, so this is less than 0. Therefore, this function is decreasing.
Yes, sir.
Lerato, okay, here is my question. Lerato and Puti, listen.
Yes, sir.
The wheels came off when you calculated the second derivative.
Okay, say.
Nice. Okay. Now let me not say the wheels came off, completely came off. Is your table of signs similar to this one that we are having in front of us?
After like solving from the first derivative, now I'm here where you are, say.
Oh, okay.
Yes.
Lerato, Putin, are we in agreement about this table?
Yes, sir. Yes, sir. I agree.
Yes.
Now, remember, the next thing is to take the critical points one at a time, substitute where? In the original equation. All right, our critical points are 0 and 3/2. What is f of 0?
0.
F of 0 is 0. What is f of 3/2? What did you get?
Yes, sir. I was still busy doing a dish. I didn't get to the final answer on that one.
Okay, let me.
I got 27/16, sir.
Okay, 27
Lerato,
over
you got 27/16.
16.
Okay, let me double check it from my side.
Okay,
So,
let me check as well.
This will be 2. This is 3/2. 3/2 to the power 3.
Yeah, she's correct, say.
Okay. Then the CD agrees, so this will be 27/16. Puti, are you calculating? Should we wait for you?
Yes, now said it's correct because he preferred to more 27. The denominator was struggling, but I get it now, sir.
Okay. So now 0 and 0. 3/2 and 27/16. 0 and 0, 3/2 and 27/16. Which one is the relative maximum? Which one is the relative minimum?
Okay, so for me, the 0 and 0, I took it as the minimum.
Mm-hmm.
And then the other one is the max. I also use the table, seeing that from interval 0 and 3/2 to interval 3/2 to positive infinity, it's increasing to decreasing, meaning the change, it shows us a local maximum, relative maximum, the change.
Oh, all right.
Yes.
Okay. Up to so far, the most important things are our critical values 0 and 3/2. This table of signs, the mean, relative mean, and the relative max. Now, do we all agree up to so far?
Yes, sir.
Yes, sir.
All right. Now, here is my request. One of you, anyone, please, I would like you to explain this graph in such a way that we will be able to see it on the Cartesian plane. We'll be able to see its movement on the Cartesian plane. Do you get me? Yes, no? Oh,
So
this is what
we get
this is
you,
what
but
this is what I'm saying. You see, like here, from the interval negative infinity and -1, the graph was increasing, and then you also tell us where the relative maximum is. You also tell us what is happening in the next interval. You also tell us the relative minimum. You tell us everything. So that is what I mean when I say, on the Cartesian plane, please explain the graph to us in such a way that we'll be able to understand how it is looking like. Do you get me?
Yes, sir.
Am I asking too much?
yes,
But do you have the graph in front of you?
Yes, sir, but it looks funny.
yes. True, it looks funny.
Okay, so I
Yeah.
can try and explain because I think I forgot to do the part of identifying the relative max and minimum, but I'll try, sir. And then my family members can help me.
Yes, please. We are
Okay,
here with
so coming from negative infinity, approaching 0, we found that the graph was increasing because the second derivative sign in that interval was positive. Then, in the next interval from 0 to 1 and 1.5, or let me stick to the fraction, from 0 to 3.2, we found that it was also increasing. Okay, wait, let me first explain the interval and then I'll explain what my graph looks like. So the first interval, we found it's increasing because the sign of the first derivative is positive. And that interval was negative infinity to 0. The second segment or interval was from 0 to 3/2, and we found that also to be increasing. Then the third interval was 3/2 to positive infinity, where we found the sign of this first derivative to be negative, so it's decreasing. So from left to right on the number line, we have increasing, increasing, decreasing. Because of the increasing and increasing on the left-hand and right-hand side of the 0, I would say then we don't have a maximum point there because there's no change in the function's gradient from negative to positive or from increasing to decreasing. It's just the critical point we have there then at 0. So on the graph, I'm assuming we wouldn't see anything funny. We just see the graph increasing through that interval, those two intervals. It's increasing from negative, approaching 0, it's still increasing, passing 0, it's still increasing. But then at what is it? 3/2, we have a maximum point. Yeah, we have a maximum because we have the graph going from increasing to decreasing on the left-hand side of that 1.5. On the left-hand side, it's increasing. On the right-hand side, it's decreasing. So it's then going to increase approaching 1.5, and then after 1.5, it's going down towards negative, and then it carries on going down on the right-hand side of 3/2.
Okay. Thank you, Lerato. That is the explanation that I requested. The whole idea was for me to just have a bigger picture of how the graph looks like. Okay? And then at the end, then you will have this. Do you see these bullets?
Oh, yes, sir.
Yes, sir.
Then you will have this. Now, remember, in this case, from that table, Lerato already explained that, but then you will summarize it nicely in this way from the graph. in this way. Are we together? In a nutshell, you will just be summarizing that graph like this. You have got all the information. This information, you have it. Am I not telling the truth?
You are, sir.
You are, sir.
Okay. Now, this graph. Okay. These are the critical points. Okay? Yes? 0 and 3/2 are the ones that we got, eh?
Yes, sir.
Then the critical values are 0 and 3/2. Then the intervals, minus infinity and 0. 0 and 3/2. 3/2 and positive infinity. We agree. This is what we have, eh?
Yes, sir.
Yes, sir.
Then we had that table. Where is the table? This is then yes, this is the same thing. This is that one. Now okay. They chose okay, let me see. In this case, we chose -1. I can't remember who said -1, but they also chose
-1.
They chose -1. Then we said we found the first derivative to be increasing. Okay?
Yes, sir.
Please help me out here. 3/2. Oh, 3/2 is 1.5. That's why they chose 1. So 1 is between 0 and 3/2. Do we agree?
Yes, sir.
Yes, sir.
That's why okay. Choose simple numbers. In this case, you chose half, but no problem. That is just my advice. Okay? Then we chose half, one number. Then we realize, but f is increasing. We agree.
Yes.
Then 2 was chosen in our case. Then we realize that the first derivative was negative, which was -8. Then is decreasing. Then the corresponding values from the critical values are 0 and 0. And f of 0 gave us 0. F of 3/2 gave us 27/16. This is the relative maximum. Then, Lerato, I heard you complaining about the graph. This is how the graph looks like. Is your graph looking like this?
Yes, sir, but it's not looking as curvy, if that makes sense.
Oh, it's a straight line. Oh, are you saying?
It's not a straight line, sir. It's just obviously for the maximum point, I know for it to look concave down.
Mm-hmm.
And we haven't done we haven't touched how the second derivative helps us sketch. So I didn't use the second derivative to help me with, the shape of it. But it makes sense.
We are not yet there. Mm-hmm.
Yes.
But is the shape completely different from this one?
No, sir.
Okay, thank you. Who should I go to? Hey, Lesedi.
Yes.
Oh,
Sir.
the wheels came off, because of the second derivative, no?
Yeah, but like now I can see, and then after like I to explain everything and put I do understand.
Okay, thank you, my sister. Futhi,
Yes, sir.
are you having something like this?
Yeah, almost, sir. I'm happy. Yo, I thought I was crazy, but it's almost same. I was spot on.
Oh, okay. Thank
Yeah, thank you, sir.
you. What should I say? I need to sum it. How can we sum this type of an exercise? Who can sum it to say, if you've got this, this is what you need. We are still on the first derivative. You need to get the first derivative. From the first derivative, you put the first derivative to be equals to 0. Then you get the critical values. Okay? After getting the critical values, the next thing that you need to do is to establish the intervals.
Yes.
Yes.
After establishing the intervals, the next thing that you need to do is to choose the test values.
Yes.
After establishing the test values, then you draw a table of signs. Okay?
Yes, sir.
Meaning you substitute the critical values in the first derivative. Answers that you get there. If a number is positive, when you substitute in the first derivative, if a number from the test values that you substitute in the first derivative yields a positive number, the sign of the first derivative of the substitution of that number is positive. Otherwise, if it is negative, then this, if it is negative, the sign is less than 0. If it is positive, the sign is greater than 0. If it's great, the sign is greater than 0, that tells us that that function is increasing. The function is less than 0, decreasing. That is why I'm saying, okay, from that table of signs, are you able to make from that table, that the one that you created, please be open and honest. Or is it helping you to can be able to determine the shape of the graph? According to the intervals. Is it not helping?
Yes, sir.
It's helping, sir. Because you know where it's increasing and going up and down. In terms of the slope. In terms of the slope, yes, going up and down.
Yes. Yes. That is why it's important to have that table. Then finally, you'll use these points. You'll use these points, you'll use this point, then you will interpret how the graph is. Then you are done. That's it. You just need to know that this is what I need to do. After that, this is what I need to do. This is what I need to do. Then this is how I need to conclude. And that's it. For sure, now it is even boring you.
No, sir.
No, sir. No.
No.
No. Now let me
Sir,
Yes.
Sir, before you move on, yesterday I thought I took a picture of the original sign table, so I didn't. Can I please take the picture?
The picture of?
The original sign table.
Sign table.
Yes, the one that we are referring to draw our graphs, the original one.
Are you referring to this? Or the previous one?
Not the previous one, the original one. Don't we have the original one?
Here? We are not having it here.
Not this one, sir, no. Yeah, no, yeah, oh,
This one.
no, sir, please scroll again. Like, yeah. Yeah, this, yeah, this one. So can I please see this one? Because
Okay.
I thought I took a picture yesterday. Thank you.
Thank you. Now, let's go to we can be able to do all of them.
Wait, sir.
All of them. I'm not even going. Sorry?
Can we see the summary that they gave us at the end
summary.
after the class? Yes, sir. Because I wrote one up myself, but
Okay. That is the summary.
so where they say the second bullet point where they say the function has a critical point at 0, 0, which is neither minimum nor maximum. I just mentioned that it's an x-intercept. Is that fine? Or
As the x, that's the x.
because I
Okay,
know an
let me-
x-intercept can also be a turning point. On some graphs.
Before I open my mouth, I need to understand what is it that you are saying that.
No, so I was just saying for the second bullet point in my bullet points, I just mentioned it. I just said that the function has an x-intercept at x equal to 0.
Oh, okay. I get you. Because there is no relative minimum here.
Yes, sir.
Hmm.
Thank you, sir.
You're welcome. I've got a packet of chocolates for all of you. Is that it?
Yes, I'm still here.
Do you like to have these chocolates?
Yes, sir.
Okay. Now I'm going to give all of you the chocolates that you deserve. Okay.
What are the chocolates, sir? Homework questions.
Lerato. When giving you chocolates. Giving you chocolates, my sister. Why?
Yo.
My boss is going to distribute them to you. Don't worry.
Okay,
sir.
sir.
Yes, don't worry. You're getting your chocolates. Okay. Your chocolates are here. Find the relative extrema of each function. If they exist, find the relative extrema of each function if they exist. List each extremum along with the x value at which it occurs. Then sketch a graph of the function. All right. I'm not angry at you, no?
No, sir.
Okay, sir.
Okay.
That's fine.
You just want us to be better. You want us to be able to do these questions in 3 minutes, 2 minutes.
Yes. Please listen attentively. My numbers don't need to be repeated.
Okay, sir.
They are not. Remember, they are not like that number that someone had to say. Listen. What did he say? Listen properly or listen what? Remember that that money that was written down on another paper, in another year.
No, man, sir.
No, sir, we're clueless.
That clueless. I don't want to go to jail.
Yes.
I know where you're going, sir. Let's just leave that one.
And I think not long time ago, another one said, hey, someone was mentioning numbers, and then someone said, hey, numbers. I hope you understand who I'm referring to, the people that I'm referring to. Okay. Please take the screenshot of number 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, and 29.
No, Jaja Buthat.
Yo.
Say you, I'm crying. I'm fighting for my life. Say you.
Believe me, once you master one, you will master all.
Okay.
Yeah, we're gonna struggle now, but it's all gonna be worth it, guys.
Yes.
When we are writing next month, we're
Mm.
gonna chow them.
Number 1, number 3, number 5, 7, 9, 11, 18, 15, 17,
Okay.
19, and 29. I think all of them that I've mentioned are here except 29. Please tell me when you've taken the screenshot of all of them so that I can show you number 29.
Okay, say.
You can show us.
Sorry?
I've taken my screenshot, sir.
Maybe I should expand. Are they all clear? 29.
Yes, sir.
Yeah. Okay. Let me move this here. Let me move this. Oh, yeah. Now everything is here. Can just take a screenshot.
Okay, so you're done.
Are you?
Yes.
Yes, sir.
Any question from anyone before we call it a night?
So, sir, you want them when the answers for the chocolate.
These chocolates. These
These are our
chocolates. When
This
we
our
meet,
chocolate putty, I guess.
yes,
I thought Sir wants the chocolate bag.
These chocolates. When we
have
meet,
11 chocolates each, guys. How lucky are we? Yo, I'm gonna have a sugar high.
yes.
For the weekend.
When we meet, when we meet, then I'll request you to give me back my chocolates. Don't eat them.
I say.
Okay.
Yes.
Okay, sir.
Just keep them. Yeah, please just keep them for me.
Okay, sir.
Then is there, oh, okay. After you giving me back these chocolates, then we'll then go to, I'll tell you, we'll then go to using the second derivative test, the second derivative to find maximum and minimum values and sketch the graphs.
Okay, so.
That's where we will go.
That's gonna be in 2 weeks.
We'll discuss it next week or how we moving forward to October. What is it that we are going to do? How are we going to start? So let's discuss the way forward after we finish. We wrap up the September month.
Okay.
Okay, man.
Please take care.
Bye.
Bye.
Bye.